Please title these notes Graphs 14 Notes, Tricky Computations, and write today's date. By the end of this lesson, you should be able to do graph analysis problems that are computationally difficult. Let's find the x-coordinates of the inflection points of f of x if f double prime of x, notice we're being given the equation that we need, equals x squared minus 2 squared g of x. And we don't know anything about this g of x except that g of x is less than 0. And notice what this means. This means g of x is always negative. So we want inflection points of f our positive negative translation is f double prime of x. So we can come over here, we already have our f double prime of x equation. We can figure out where this equals 0, x squared minus 2 equals 0 versus g of x equals 0. We're told that g of x is always greater or less than or equal to 0, so this one's never going to give us a 0. And for this one, there's not really an easy way to factor this, so we're just going to have to solve it a slightly different way. We can add 2 to both sides, so x squared equals 2, and then just take the square root of both sides to get x equals plus or minus, be really careful with that, the square root of 2. So those are the only numbers we have, so negative root 2, positive root 2. And we don't know without a calculator exactly what the square root of 2 is as a decimal, but we do know the square root of 1 is 1, and the square root of 4 is 2. So the square root of 2 must be somewhere in between negative 1 and negative 2. So if I pick like a negative 100 or something like that, and I put this in for my factors, g of x is always negative, but when I put in negative 100 squared, it's going to be positive, minus 2 is still going to be positive, squared is going to be positive. In fact, if I look at this squared right here, that's actually going to tell me that this factor is always going to be positive. So no matter what, this is always negative. This is concave down, and concave down. So this is actually a trick question. This never changes concavity, this f of x. So f of x has no inflection points. Because f double prime of x never changes sign. So f of x never changes concavity. These points here are really just fake outs. The f double prime of x is briefly equal to 0, but then it just goes back to being negative, so we don't have an inflection point. Another couple of types of tricky examples involve natural logs and absolute value. So let's find the x values for which f of x is concave down if f double prime of x equals the natural log of x minus 1 over the absolute value of x plus 3. We do the same charts that we've done. We already have f prime of x, or f double prime of x, and it's as factored as it's going to get. So all we have to do is figure out when the natural log of x minus 1 equals 0, versus when the absolute value of x plus 3 equals 0. So these ones, x plus the absolute value of x plus 3 equals 0 when x plus 3 equals 0, so when x equals negative 3. This one's a little bit trickier. We have to solve for x. So we'll need to add 1 to both sides first. Natural log of x equals 1. And then we can undo this natural log by doing e to the power of both sides. So x equals e, or e to the first power. Remember, this e is approximately equal to 2.718. So negative 3 is down here, e is up here, and then we have these two factors. One for the top, one for the bottom. One for the numerator, one for the denominator. Now, the nice thing about absolute value is absolute value turns whatever is inside it positive. So that one's really easy to take care of. But figuring out here, for what values of x is this negative versus for what values of x is this positive, that's a little trickier. So let's remember a couple facts about logs. When x is less than or equal to 0, this is undefined. When x is between 0 and 1, this whole thing is negative. And when x is greater than 1, the log is positive. So, actually, if we have any x's that are less than 0, we actually just flat out can't put them in. So we can actually end our sign chart right here. I'll do this in a different color. We can actually end our sign chart at 0, because down here we're going to get undefined, because we can't put a number less than 0 in for x. So all we're looking at is whether a number is less than e or greater than e. There's one additional fact to remember. If we put 1 in here, if we put x equals 1, this is going to give out 0. So if we pick the number 1 here, which is less than e, and we put it in right here, we're going to get the natural log of 1 is 0, 0 minus 1 is negative. If we have a very large number, we're going to get out a very large positive number. So we have overall a negative and a positive. So that means, again, we stop at 0. Got a change here at e. This is concave down, concave up. So that means that f of x is concave down when 0 is less than x is less than e, because f double prime is negative. For our final problem, let's find the x-coordinates of the inflection points of f of x on the open interval 0 to 2 pi, so that means not including 0, not including 2 pi, if f double prime of x equals the sine of x. So we'll do our same charts, f of x, concave up, concave down, f double prime of x, positive and negative. But now it takes us a little bit of work to figure out where is the sine of x going to equal 0. So let's draw our little quadrants. We've got 0, pi over 2, pi, 3 pi over 2, and 2 pi again. And remember that sine is the y coordinate. So we know this is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. And so we're looking for between 0 and 2 pi, where does y equal 0? And it's right here and right here. Now we said not to include open interval, not including 0 and 2 pi, so we're not going to include those. We're just going to include pi. I'm just going to cut this off because it said we're only on this interval. So we've got pi right there. And we can see that the sign being the y value means that the y value is positive from 0 to pi, negative from pi to 2 pi. So we've got concave up here, concave down here, and our inflection point is right at pi. Because f double prime of x changes sign. So f of x changes concavity. This concludes Graphs 8 notes. Please title. So let's find any intervals where f of x is decreasing if f prime of x equals -3 e to the x natural log of x over the absolute value of x. Decreasing means f prime of x is negative. Thank heavens we already have f prime of x, so we don't have to do anything with the derivative here, just make our sign chart. So we want to first figure out what the critical values are, what makes this be 0 or undefined. So we've got several factors here. We've got this -3, got an e to the x, a natural log of x, and an absolute value of x. So we've got critical values wherever any of those equals 0. So first we say, what makes -3 equal 0? Well, nothing. -3 always equals -3. So, no number to put on. What makes e to the x equal 0? Well, one of the things that we reminded ourselves of in the past is that any exponential function, something to the x power, is always positive. If we were to graph it, it looks like that. If we start off with a positive base, there's absolutely no number that we can put in for x that will make it be negative. It just does not work. A negative exponent just moves it to the denominator. So, there's no number that will make this be true. Natural log of x. This is a little bit trickier. If we happen to have a graphing calculator, we can just enter the natural log of x, graph it, and then we can see if we look very, very, very closely that it's undefined over here where x is 0, it's negative from x equals 0 to x equals 1, then it's positive for the rest of the time. We can also look at this here and say, how do we solve for x? Well, we do e of each side undoes that natural log. Anything to the 0 power equals 1. So natural log of x equals 0 when x equals 1. It's also just something that you really, really, really ought to know. The natural log of x looks like this. It's positive when x is greater than 0. It's negative between 0 and 1. And it's undefined over here. So these are just facts to know. Write them on your flashcards. You really just have to memorize them. It's going to save you a lot of grief. Okay, our final one is absolute value of x equals 0. Well, when x equals 0, if we make it positive, it still equals 0. So we actually only have two numbers to put on our sign chart, 0 and 1, but we have 1, 2, 3, 4 factors. -3 is always negative. We just said that e to the x is always positive. Natural log of x, this is one of the things that's just in our facts to remember. It's undefined when x is less than 0. So it just says undefined. Between 0 and 1 it's negative. Greater than 1 it's positive. And then the absolute value of x, well, absolute value turns things positive. No matter what, this is always positive. So one of the first things to look at over here is that we've got something that's undefined. So that means that this just flat out doesn't exist. We're just actually going to stop the graph right here because nothing else is going to happen. Here, 2 negatives, 2 positives, overall that's positive. 1 negative, overall that's negative. So f prime of x is negative when x is greater than 1, meaning f of x is increasing there and decreasing there. So we would say that f of x is decreasing when x is greater than 1 because f prime of x is positive. For our second to last problem, let's find any intervals where f of x is increasing if f prime of x equals x minus 10 over x. Now, increasing means f prime is positive. So we already have f prime of x, so that's good to go. Now we just need to do our sign chart. The tricky thing is that these are separated by subtraction. So in order to do our sign chart, we really need to have these in something where we only have multiplication and division of factors. So let's first do common denominators here. And this doesn't factor out very neatly. But what we can say is we can just leave this as one factor and say when this whole thing equals 0, then f prime of x equals 0. That's okay. When x equals 0, the whole thing is undefined. So to solve for this, all we have to do is add 10 to both sides, take the square root, but remember, when we have an even exponent, it has to be plus or minus the square root of 10. So we have 3 different numbers, even though it looks like we only have 2. We have x equals the square root of 10, x equals the negative square root of 10, and x equals 0. Not quite sure what the square root of 10 is, but we do know the square root of 9 is 3, so it's going to be somewhere around 3. So we've got negative root 10, 0, positive root 10. My equation here is f prime of x equals x squared minus 10 over x. So we're really thinking of it as only 2 factors. Let's say this is a very, very, very negative number. Well, x squared, anything squared is going to be positive, so it's a very, very, very positive number, minus 10. It's still going to be positive overall. A negative number for x is just a negative number. Let's say x is between negative square root of 10 and 0, so call it like negative 1. Negative 1 squared is 1, minus 10 is a negative number. Negative number is right there. It's positive overall. Between 0 and 10, so positive 1 squared minus 10 is still a negative number. Positive number is a positive number. Here, if it's a very, very large number, minus 10 is still going to be a very large positive. positive number is positive, it's positive overall. So that means that because f prime of x is negative, f of x is decreasing, increasing, decreasing, and increasing again. So that tells us that f of x, f of x is increasing on the intervals negative root 10 to 0 and root 10 to infinity, because f prime of x is positive.